advertisements. I think Eat Fresh is a great slogan. They managed to convince the entire continent, if not the globe, that eating a foot of bread was somehow good for you.
Good afternoon, everybody. Welcome to class today. As we get started today, just a couple of announcements. One is that my goal is to have Module 10, which is going to be the last module that we'll be covering in this course out on Thursday. Still got a good amount to do on it, although I think I can get it done pretty quickly. We'll start working on it tomorrow. We'll get it out on Thursday. Again, I kind of want to apologize. I don't know if that's the right word. I'm one of these people who normally likes to have a class that's completely ready to go before they start the semester. And this semester in particular, there were 2 classes that weren't built yet that I had to rebuild and start from scratch. So I've spent this entire semester just trying to kind of stay ahead of everything. And it's been working up until this point. I wish I had more done, and I wish it probably was better. But it kind of is what it is. I think a lot of you have done really great jobs with what you've been able to produce. I really like what I've seen in terms of projects coming out of this course, and I think it does well, and it kind of proves that maybe going for a more project-heavy course, while it is more work, it is only 1 project per module, in fairness, and you guys have been turning in some really great stuff. I've been seeing some really great stuff out of this course, and it kind of shows that with the practice and with doing things more and more and more and over and over and over again, just getting that practice, how much practice helps you grow as we learn these new skills. So I think that's pretty crucial. So look for that module sometime on Thursday, and then we'll discuss how we're going to handle that kind of, as we glide into the end of the semester, right? Like after this week, there are like 2 more weeks or so in the month, and then like 1 week in December, and then we'll be done, or maybe 3 more weeks in the month, just whatever it is. Right, so that takes us right to the end of the semester. So we'll talk about what we'll be doing with the rest of the semester, essentially next week, after we have all that out and available to you. We'll also be posting the final project on Thursday as well, because once we get one done, like the final project's already ready, like it's already in there, like there's the element already in there. I just haven't opened it up yet because I wanted to kind of get all the modules out there before I did the final project, posted the final project, just to maybe put your fears at ease just a little bit. Because the final project is a game, but 1, it doesn't have to be a complicated game, and 2, we'll have a lot of time to make it, and our live stream for that week will just be kind of a game jam where I'll get on and just make a game myself, and maybe you can take ideas from that or whatever. Right, so that's that. And I think that's all of the announcements that I have for today. So we'll go ahead and get on into the content for this module, which this module is about JavaScript objects. And JavaScript objects in particular are really interesting. So we look at JavaScript objects, and we also look at Json in this module. And as we'll talk about here in a little bit, Json is different from a JavaScript object, even though Json stands for JavaScript Object Notation. It's different from objects, or a regular JavaScript object, but they're written similarly, and they kind of work similarly enough to where we can kind of talk about them together. So we'll look at objects a little bit, and we'll work with objects a little bit, and then I'll do an example that uses Json, because that's really probably what you're going to want for your lab assignment for this week, as you are bending to the Ham King's will yet again. I will be working in Replit today as opposed to Visual Studio Code, just for the ease of access to the console, because we'll be doing a lot of console demonstrations. But as we're outputting things to the console, just remember that we could also do whatever we want with this stuff that we're outputting to the console. We could add that to a site as an inner HTML element. We could change elements based on class or style, or some kind of attribute or whatever, right? Like, so these are examples, and then we can take these examples and we can use them however we want to use them. Right, so I think the first thing that we need to do here is we need to define just what exactly is an object. So when we're talking about what an object is, an object is just a collection of key value pairs. For those of you who have already taken CIS 115, which I think should have been all of you, might be one or two of you that haven't taken that course yet, the Python course, we discussed dictionaries in the Python course. And, we talked about how a dictionary is a key-value pair. We have a key on one side and a value on the other side. And we can put multiple of them in a dictionary. And really, a Python dictionary is very, very similar to a JavaScript object. In some other programming languages, you might have heard of something called a hash table. If you've delved into some other programming languages, like as you play with stuff and as you've researched stuff on your own, you might have heard of something called a hash map, which is where we use a hash table to kind of map data. And so these hash tables and hash maps, it's very similar to what we see in a JavaScript object. We got a key on one side, we got a value on the other side. And as we were talking about a couple weeks ago, when we were talking about the ideas of truthy and falsy, it's been probably 2 weeks, maybe 3 weeks now since we were approaching those concepts. We were talking about the different data types that are in JavaScript, and we noted that a lot of them are what we call primitives, things like number and Boolean and string, right? These would be primitives. But an object is not a primitive. An object is something completely different, and when we're dealing with objects in JavaScript, there are other elements in JavaScript that kind of have the object at the foundation of it, which is why we say that objects make up the foundation of everything kind of interesting in JavaScript. Like an array in JavaScript kind of has an object at the foundation of it that kind of helps it out there. There's a lot of stuff that we have with objects that make things a little bit interesting. So we use these objects for multiple purposes. There are predefined functions and predefined things in JavaScript that are based on objects. Again, we're kind of keeping this at a really high overview here in this lesson, just because we've got a week to kind of look at objects and play with things, so it's tough, right? But when we're looking at an object, we can kind of look at how an object is organized. And when we're thinking about these key value pairs, we can kind of think about these key value pairs in similar terms to what we would talk about when we're talking about, say, CSS, right? Like when we look at a CSS set of rules, for each of those rules, you have a property and you have a value, and we can kind of look at the structure of a JavaScript object similarly, where we have sort of this property, and this property has a value. And, that's that key value pair there, right? We get a name for this property. This name can be essentially whatever we want it to be, as long as we follow the same sort of naming conventions that we follow for everything else, right? Like no symbols except for an underscore, can't start it with a number, that sort of thing. So we can take this name and name it really whatever we want, kind of like we would work with a variable under those same, variable naming conventions. And then we assign a value of some sort to this named property. And so a property name is a unique value that can be coerced to a string that points to a value. Right? So what we're saying here is that we can have this string pointer that is referential to a value. We'll look at that in a little more depth here in just a little bit. Right? Because one of the examples that I have utilizes a computed value, or a computed property rather, that takes a string from an array and injects it into an already existing object, and then we compute that property and it turns into property name that we can reference as a property, you know, kind of like a variable name later on. So we're taking a string and we're coercing it into this pointer that is going to be the property name that points to a value. And so our property value can be any value. We're looking at any primitive or even any other objects, right? Like we can use arrays, or we could use other objects, or we can use functions in an object property. And there are some really useful things that we can do with functions inside of object properties. For our purposes, we won't be kind of looking at that. That's kind of outside the scope of what we want to cover. But we will look at something that's slightly different, which is setting up an object as a function, so that we can utilize multiple copies of said object. But when we look at an object, we essentially see it like this. Right? This is an example of how we would write an object. So we see here it's very similar to how we would create a variable. And you see sort of the things that we would want to kind of call out here. One important thing to kind of call out as we're getting started here is the fact that we've written it as a constant. Just because we've written it out as a constant in this instance, it's okay. It doesn't matter. Right? You know, working it as a constant is fine. We can still add properties and remove properties from our object, even if it is a constant. So it's still manipula. Well, I'm not going to be able to say that. You know what I mean. It's yeah. Anyway, and then there's a little error here. That should be lowercase t true for a Boolean in JavaScript. Teaching too many different programming languages, as always. Always missing some, you always miss something. But we have these key value pairs here. And we have this object that we're calling hello world. We have this property of hello. And it's given the value of world. We have this property of doing good. And we're given the value of true. And we can take and we can reassign these values, which we'll talk about in just a little bit. We can take and we can display these values out onto our page or use them for other purposes. Right, so let's just kind of look at this object and just kind of see it in the world. So I'm going to switch over to my replit now. Let me find the right window here. I have way too many windows open. And so again, we're using a replit here just for demonstrations purposes because we have nice access to this console window, and a lot of the stuff that we'll be doing early on will take advantage of this console window. So let's create that object that we just created, or we just saw on that screen, and then we'll talk more about kind of what we see here. So we're going to create this object. We're going to start with a constant. And we're going to give it a name. In this case, we're just calling it object. I think since we're putting it into a program, let's call it something different. Let's call it like obj new. Right? And then we're going to set it equal to what we put in this set of curly braces. Now, if we were just putting one element here and stopping, like hello, and then in between there we're putting world, this is fine. Right, like you saw in our on our slide there, we had semicolons at the end of a line. Actually, this will probably error out if we put a semicolon here with nothing else in there. You know, it's one of those weird idiosyncrasies about JavaScript in this way. Right, like let's just try that. We'll talk more about how this works in just a little bit. But if I console.log obj new.hello, we'll see that we'll get a syntax error, unexpected token. If I remove that semicolon there, I get world. Right, so if I only have one element inside of my object, we put no punctuation at the end. If I have multiple elements, we put a semicolon at the end of our multiple elements. And even the last one will work, doing good true. Right, so now if I'm still calling obj new.hello, oh, it doesn't. It still does. It doesn't like it on the last one. Comma. There we go. Yeah, we should be using commas there instead of semicolons. I am sorry. I think all of my examples utilize semicolons in my slideshow because, well, I was trying to make this too quickly. So wherever you see a comma in your JavaScript object, which will also make more sense when we get to Json, because it uses commas everywhere. So whenever we see a semicolon in our objects going forward, we're going to picture them as commas, and we're going to use commas in our demonstration. Because obviously I was moving too quickly when I made this presentation. So we don't put a comma on the last one, we put a comma on every other one. So what are we looking at here? What even is this? This type of object creation is called literal object creation. What we've created here is a JavaScript literal that is an object. So in that previous example, and what we just did there, we've created a JavaScript literal object. And and you can see there that it's kind of similar to how we create variables, right? Like we set this constant, we give it a name, we set that equal to something else, and the thing that we set it equal to is in curly braces instead of just being out there for the world to see. Now there are other ways that we can create objects in JavaScript. There are multiple other ways that we can create objects in JavaScript. But for simplicity's sake, for now, since we're just trying to cover objects in 1 week, we're just going to stick with literals. So we can set an object property. So once we have an object, we can add properties to it using what we call, something that we term accessors, right? Essentially, we can use a valid property name, anything that we want it to be. And if it doesn't exist in our object, we can use it to access our object and add this property to it. So one of the things to remember is that valid property names, just like valid variable names, are things that can be coerced into a string. So, anything that's essentially not a reserved keyword in JavaScript. So we can't use function, we can't use var, we can't use return, we can't use things like that. And also we don't want to start it with a number. So let's look at an example here, and we'll just do it in our replit, where we kind of create an empty function, and then, or create an empty object, and then add items to that object with these accessors. So I'm just going to comment this out. Let me do a block comment here. We'll comment this out, and we'll create a new object. And in this case, it's going to be just an empty object, so we're going to create an object called Yeti, and we're going to set it equal to an empty set of curly braces. And so this is our Yeti object. Right now it has nothing in it. If we tried to call something like console.log Yeti dot, we're going to add the property is mysterious in just a minute. If we try to call it now, there's nothing in there, right? So if we try to call it now, we get undefined, which is interesting, right? Like we get undefined instead of an error or a lack of, whatever else, right? And it's because we can kind of access that object. We can put things into it. We can take things out of it. And we can see here that it's undefined. There is no defined value for is mysterious with our Yeti object at this point. So what we would want to do is we would want to define that value. And we can do that by simply setting our object with our dot notation is mysterious. Right, so now we have our Yeti object. We have our is mysterious property. The dot here tells my compiler that, is mysterious should be a part of my Yeti object. Should be one of the key value pairs inside of my Yeti object. And so from here, I should just be able to assign it a value. And we know that the Yeti is mysterious, so we can set that to true. Right? We'll just use our Boolean value here. So essentially what that's done now is it's accessed my Yeti object, and it's taken and it's instantiated an isMysterious property with a true value. And so now Yeti.isMysterious is no longer undefined. It's defined now. And we see now that when we run it, we get true. So we can take and we can access these in multiple ways. And we can do this as many times as we want. We can put as many things as we want to in our object from here. So we don't have to start out with a fully completed object. We can add stuff to it as we go. We can change stuff in it as we go, which we'll look at in just a little bit. Okay, but that's one of the interesting things that we can do with an object. And so as we kind of continue here, let's talk about getting and setting, because what you've just seen is setting, right? That's what we just did. We can get and set data, and really we saw both examples of getting and setting data in that last example, because we set data when we did that assignment value. Right, and we get the data when we logged it to the console. Right, so we can get and set data in an object using that same basic dot syntax. So it all depends on which side of the equal sign the property is on. So as we see here, like if we have obj.property, right, just like we had the Yeti.isMysterious equals in that example. Right, that's a setting. So we've taken that and we've got this setting here. We're setting that value to true. But in our console.log, or if we were to create a variable with that, say var t equals Yeti.isMysterious, then that's a get, right? We're getting data from our Yeti object and we're putting it here. And so now if we console.log t, for example, we would return true. We could also do some, and we can use this in our code in other ways, right? Like we could set a conditional that says like, if, and let's do this in a function. Right, const change bg if Yeti.is mysterious, right? And so this is a Boolean flag, so we can just leave it there, right? If it's true, then this will run. Otherwise, it'll be false. We can document dot select or query selector body dot style dot background color equals blue. Right, so we can employ this in our function like this, and if we add an event listener like document dot add event listener, this would be DOM content loaded change bg. Run that and we get a blue background there because it's getting that Yeti.isMysterious, which is set to be true in our object, right? And so we use this same dot notation for basically everything. And you can use a dot notation, or there are instances where you're using a square bracket notation where it kind of looks like an array. And your module talks more in depth about that, about when you would use that square bracket notation. And we're not really going to examine that today as we approach these objects. So we've got something else that we can comment out here, so I'm just going to move the comment to the end. So we can have the code and we can do other things. And the next thing that we'll talk about is computed properties. So sometimes you might want to use a variable or a part of an array, right, as a key for an object property. And so when we're using a variable, or when we're a variable name, or we're using, part of an array, one of the things that we have to do is we have to actually fetch the data that's inside of that element. We have to fetch the data that's inside of the variable. We have to fetch the data that's inside of that array. And this is done through computation, right? This is computation in our programming. Our interpreter actually has to do something to go and retrieve the value and bring it back before it creates an object. Which is pretty interesting, and it's pretty cool that we can do something like this. All we have to do is we have to wrap that name of the item in square brackets. And this will denote a computed property, and that will cause JavaScript to evaluate whatever we're trying to evaluate before it adds it as the property key. So it'll go and get that data that's in that variable container, or it'll go and get that data that's in that JavaScript array, and it'll bring it back. So for example, let's start out by just doing a variable here, and then we'll move on to something else. Like if we go back and we look here, right, at what we started doing here, our property is just the property name, right? We're just establishing it in the same way that we would establish a variable. So if we were to just type a word here that might be our variable, it would be confused as to, whether or not you're trying to start a new thing here with this property name, or you're referring to the variable. So that's why we have this computed property here. Right, so if we want to use our variable somewhere else, we can create a variable here. Let's create a variable Yeti property, and we'll set it to a string of Yeti color. Right, so now I want to create my Yeti object, and I want Yeti color in this case to be my property name. So let's create an object. We'll create a constant. We're going to call this constant of Yeti, and we're going to set it equal to our curly braces. So now we have our object structure here. And now if I took Yeti property and referenced it in here, just like I was trying to reference anything else, and had it set to, say, blue, right, and then I tried to console.log and let's do this just to make life easier on us. If I tried to console.log Yeti underscore color, because ideally that's what we would be putting there, because that's the value that's in our Yeti property container, right? It's going to return to me an undefined because it doesn't know what Yeti color is. It has a Yeti property. So this Yeti property and this Yeti property, two completely separate things. Right, so, and we'll see that if we do console.log Yeti property versus console.log Yeti property. We get Yeti color and we get blue. And ideally we should probably make these lowercase, because typically we use uppercase to like denote classes, which we'll kind of look at that in a little bit. We'll do something that's similar to a class. So if we want to take this and we want to make this property name compute the value that's in the variable, we simply wrap this in square brackets. That basically states that it exists elsewhere. So we need to find this elsewhere, go and get that data and bring it back. So now when it sees Yeti property here, what it's actually seeing is what's inside of our Yeti property container, i.e. Yeti color. So now if we tried to console.log Yeti.Yeti property, this will be undefined, right? Because we don't have a Yeti property inside of our Yeti object. We have a Yeti underscore color. Yeti underscore color in there. And when we were talking about coercing strings, this is what we were talking about, right? Because you'll see that this here is a string. We have quotes there, but here there are no quotes, right? It's been coerced from a string into just a simple property name. And if we run this, we'll see we get blue. No error, nothing like that. Now, one of the interesting things here is that we can also do this with an array, right? So if we wanted to swap this up and we wanted to do it with an array, maybe we wanted to have multiple properties here in some kind of array that we could kind of pull out. This might be something that you would want to consider when you are doing your lab, because you already have arrays that have content in them. So maybe you want to take those arrays that have content in them and bring them in here to whatever you have as a property, your object as a property. But we'll create a constant as an array. We'll call it Yeti properties. And we'll create an array of different Yeti properties. We'll call it Yeti color, hair, eyes. Right, so now we can construct this object with these properties that are inside of this array. So this is our Yeti properties. And if you'll remember back to last time when we talked about arrays, we can look at these different values that are inside of this array, and we can pick out a singular value based on, and I'm going to go ahead and comment that line out because we don't need it anymore. We can pick out a singular property from our array by identifying its index location. So our Yeti color here is index 0, hair is index 1, eyes is index 2. So in this case, we're going to keep our square brackets there. Yeti properties at index location 0 is going to provide me with Yeti color, comma. And we can just kind of copy this and put it in here again. Yeti properties at index location 1 is going to provide me with hair. We can say that's long. Yeti properties at index location 2, that's going to provide me with eyes. Let's say the eyes are green. So if we already have an array established that we can work with there, we can go into that array, we can compute the properties from that array, bring them back into our object, and give them a value, or we can also use them on the other side, right? Like, in that case, if we were using them on the other side, we could just use the variable name. Right, like if we had another, like if this was green, we could just use Yeti properties 4 here. Right, and we don't need that comma on the end of there because that will cause us an error. So if we want to, right, and that's not 4, that's 3. Blech. Long day. So if we want to get Yeti.eyes, since the item here at index location 2 is eyes, when we compute this, it'll go, okay, Yeti properties, that's our array. At index location 2, 0, 1, 2. So this is actually called eyes. Yeti properties 3, that we're assigning it here, is the item at index location 3. So we should get green, which we get right there. And so this is how we're able to use this object. Here's another example of that as we approach these computed properties. And we can see we have this array here of different animals: dog, cat, and rabbit. You know, I might be using that array for a different purpose. So we want to kind of, you know, apply the dry principle to our code. We don't want to repeat ourselves. So if we're already using this array and we already have this array value for something, or if we want to use this as a part of something else, we can create this object here. We call this object feline. We've got animals 1 inside of square brackets, which means it's going to be a computed property. Animals 1 is going to go back to our animals array, look for 0, 1, which is cat, and it's going to bring it back to here as the property name and get it and assign it the value of true. So when we log feline.cat, we get true as the result. Now, before we can talk about the next thing, we're going to have to get a little technical, because I want to talk about referencing objects and how objects handle reassignment. Because when we are referencing variables, we're doing something very different. Right, so before this, I just want to show you just a little example to remind you of kind of how things work. So let's add this to our code here. If we create a variable, in this case, let's call it x, and we assign it the value of, you know, some number, let's say 27, and we take a new variable and we assign it the value of y, or we call it y and we assign it the value of x. So let's say for a moment we've done this in our code. Right, we have a variable, we've assigned it called x, we've assigned it a value of 27. We have a variable called y, we have assigned it x. So what happens here is, as our interpreter is kind of interpreting this code, we have this value x here. It's going to go to this x variable container. It's going to get the data out of here, and it's going to return it back here. So this y essentially becomes a copy of that data that we have in x. So y becomes 27. right? So if we console.log both of these, console.log x, console.log y, we see the result. They're both 27, which makes a lot of sense. But if after assigning x to the value of y, we decide to change x, right? Like let's say we reassign the value of x here. Maybe it's 39 now. That's not going to change the value of y. It took the data out of this container and put a copy of it in our y container. So even though we changed the value of x here, we've not reassigned the value of y. So it's still 27. So if we run this now, x is now 39 because that's what we've reassigned it to in our flow of execution there on line 40. And our y is still 27. If we look at our console here, we see 39, 27, exactly what we would expect. Objects don't work like this, because objects don't exist in stack memory. Objects exist in heap memory. We might refer to it as being in the heap. Right, so we need to kind of clear up the idea of memory use in JavaScript. The vast majority of things that we do in JavaScript, I think everything that we've ever done really in JavaScript is done in the stack. But objects go into the heap, which is a little bit different. So this actually makes a huge difference in terms of how we can reference an object and what we can do with said object. So just what is the stack? What is the heap? Well, I got a couple slides here with some properties of both of these. When we're thinking about the stack basically is our regular linear data structure. Right? It's our normal flow of execution that we're putting our program in. So it allocates this one large contiguous block of memory, and that's what it runs. Right? It's not gonna. We're not bringing data in and out of there. We're not closing off part of this memory and then opening it back up. It's just one open block of memory that is opened up when it starts to run the program. And this memory is handled by the compiler, which is nice. So in this case, it's handled by our browser. Right, and as the stack size grows, the amount of memory that we need for the stack grows, which, since the browser is handling it and allocating that memory, that's what typically causes the slowdowns in your browser. When we're dealing with heap is a hierarchical data structure. And when we're dealing with heap, if something is on heap, we are allocating a fragmented block of memory for that particular thing that's on heap, that's in use at that time. And then if it's not being used, we can unallocate that memory and free that memory up. So this can cause the memory to become fragmented because we have blocks coming in, blocks going out, and as we have these different blocks coming in and going out, that's going to fragment the memory. And we can allocate this memory in any random order that we want to allocate it. And instead of our browser, since we have to kind of call for it and then free it up, we're the ones that kind of manage the heap memory. Now, for our purposes in particular, we're not going to get too deep into what we can do with heap memory. But it does have a meaning for us when it comes to objects, because our JavaScript objects are stored on heap. So our JavaScript objects are stored as a part of the heap. So because of that, whenever we reference a JavaScript memory item, for example, if we want to take a JavaScript object value and put it into a variable, and then when we reassign that variable, what we're reassigning is the reference to the object. So we're actually changing the object as well. Right? Unlike what we saw in that example that we just did a couple minutes ago, where we took the variable, we passed that variable to another variable, and then we reassigned that first variable. That previous value still existed in that other variable. It's going to change that initial object. And so when we look here, like this is an example of that, and we'll do a demo of this here shortly as well. When we look here, we see, well, we're creating our Yeti object. We're adding Yeti.isMysterious, and we're setting that equal to true. Then we're taking a value of y, and we're passing Yeti straight to it. Right? So we're taking that whole Yeti object and we're putting it in y. Now we could call something like y.isMysterious, and that's going to work. That's going to return true. But y is not a copy of Yeti. It is Yeti, just in a different container. Right? So if we change the value of isMysterious, even if we change it in y, where we have y.isMysterious equals false, that will change the value that is in Yeti to false. Right, so let's look at an example of that. Let's check that out here. So we've seen this example of how our variables work. Our variables on stack work in that way. So now let's see it with an object. Let's create an object. We'll create an object called const trees equals our object notation, and we'll call it primary : apple, right? So now we have this object, we have our primary as an apple tree. So now let's take and create a variable. We'll call this variable primary tree. And we're going to set it equal to the value of trees.primary. And if we console.log primary tree, we will get, let's put our semicolon here, we'll get a syntax error. Oh yes, because it doesn't want that semicolon there. Oh no, it doesn't want that semicolon there. Right, we want one here. No semicolon goes in my object. We get apple. We get apple. Right, so trees.primary, we set that to primary tree. But now what's happened here is that this variable isn't apple. This variable is trees.primary. So if I reset my variable primary tree and reset it to oak, that would essentially be the same thing as resetting trees.primary. So if I tried to console.log trees.primary here, we get on our output, oh, we get apple. So that works. It must just, didn't think about that one. We should be passing the whole thing here. Yeah, this should be trees, and this should be primary tree dot primary. Yeah, and so now it's oak. Yeah, so with our individual key value pairs, we get that in the stack, so we can make different. We can work with that a little bit when we're using our entire object. Our entire object is in the heap, which is why we see this is not specific. This is a copy of. This is not a copy of this object. This is this object that we're just putting in another container. A little bit tricky to kind of wrap your head around, which is kind of apparent there. Let's look at one more thing about regular objects, and then we'll move into JSON, and that'll be our object functions. And these are kind of interesting because if we want to take an object and we want to make multiple of them, one of the easiest ways that we can kind of do this is to create an object as a function. And if you've worked with any object-oriented programming like Java, we can kind of look at these object-oriented functions similar to the way that we would work with classes. Right? So when we have one of these object-oriented or object functions in our JavaScript, we want to start the name of that function with an uppercase letter to denote that it is a class. So what we've done here is we've kind of created a template that we can use to create other objects based on whatever we have, and we can actually use this with loops and things of that nature, right? And so that's some pretty fun stuff there. So one of the things that we need to note here, though, is that we can't use the arrow function notation to do this. Right? Because in the example that I'm going to do here, I'm going to create this in such a way that we need to use the this keyword. And so when we use the function keyword to establish our function, the this keyword is scoped to that function. So when we say this, that will be specific to whatever object you're creating. So we can actually make multiple copies of objects utilizing this function and different data by using the this keyword to kind of establish a template of sorts. Now, if we did arrow notation, in an arrow notation function, it looks at the this keyword as the global this keyword. So it wouldn't be quite the same. It wouldn't understand it quite the same. So let's do an example of this and we'll see it in action. I'll do a simple one and then I'll do one that's a little more complicated. So in this case, I'm going to write a function called animal. And notice there that my animal is written with a capital A. And into this function, I'm going to pass as many arguments as I want to pass for as many object properties that I need to assign values to. Right, so if I want to kind of have the property the same for everything, I don't need to pass an argument for it. But if I want to have an argument or have a value that's different for every new object I create, I need to pass it into there as an argument. So in this case, I'm going to have a name, I'm going to have an icon, and I'm going to have the number of legs, which we'll just call legs. So now in my function, I can add this dot name and set that equal to name. And that name here is different from this name here. right? This name is our argument name value. This dot name becomes the name of the property of this particular function. So in this case, what it will kind of play out to is name equals whatever value we bring in. And so we'll do that multiple times. We'll do that this dot icon equals icon. This dot legs equals legs. And so now we'll create some new instances of this particular function with different data. And that will create a new object for different things. So for example, if we created a constant called dog, in that we could set a new animal, which means a new version of this animal object, and we can pass into it some values. Name is dog. Icon is, I was using emojis for this, so let's pull up our emoji keyboard and type in dog. And then number of legs is 4. Right, so now I've created an object for my dog that uses that template. So if I console.log dog.icon, I get the dog from whatever I named my constant here. I get the icon from my object. I run that, and I see my little picture of a dog. I see my little dog emoji in my console window there. So this would be the kind of thing that we kind of want to do if we were to say, want to take several of these and put them into like a template or something that, you know, maybe we want to have like the icon, the name, and the number of legs inside of a thing. Right? We can take these and we can put them in an array, and we can take that array and we can do some various things with it. Right? But we could also take a constant called chicken, and that's also going to be a new animal. So we're creating another new instance. We're creating a new heap memory block of this animal object. We'll give it the name of chicken. We'll give it the icon of, I like that one. And a chicken has 2 legs. And so now we can console.log chicken dot name, and that'll give us that uppercase chicken value there. So we could also put these in an array, right? Like we could create a new pets array and set that equal to an array of dog and chicken. And this was actually something that I wasn't quite prepared to do here, so I might get the syntax a little bit wrong right now. But what else is new? We'll figure it out. So we'll write a for pet of pets console.log pet.name. Invalid left hand assignment. So, oh, I put new here. I meant to put var. Yeah. Dog and chicken. Right? We can loop through these objects, and we can loop through, and we can get their various, like we can put their icon in there as well. Like pet dot icon. Concatenate that with, maybe put a space in there. Concatenate that And concatenate that with something like has, put spaces around that, pet.legs, legs. Right, and so hopefully you can kind of see how we can work this into like inner.html as well, right? Like if we were working with an inner.html thing, we could print this out and put it on our website just the same as we could print this out and put it on our, or put it in our console rather. In fact, let's just do that right quick. I'm going to create an unordered list. We're going to need this in a little bit anyway. So in this case, all we're going to do is we're going to keep this same thing. And we will just, instead of our console.log, we will document.query selector ul .inner HTML plus equals in quotes, because we want to put those list item tags there, li pet icon. So we will close that, concatenate that, and then put a /li. Right, so that'll give us list items. Oops, forgot that closing there on the end. That'll give us list items. Dog has 4 legs, chicken has 2 legs. Pretty cool, right? And we can create another constant, whatever we want. Const cat equals new animal. Cat we get our icon here. Windows key semicolon cat. Four legs. We'll add the cat to our array here. And that'll give us another list item there as well. So that's pretty cool. Right, and this is a lot less effort, isn't it? A lot less effort doing things this way than it is like creating a whole bunch of data. Right, there's a lot less code here than there would be if I did this the long way. So this is pretty cool. Now I've got one. Now I know we're past our hour mark, but I've got one more thing that I want to talk about, and I want to do a demo for it. And that is Json. So Json stands for JavaScript Object Notation. And it's called that because it's written like a JavaScript object. It's not a JavaScript object. It has a separate purpose. The purpose of Json is to be a standard file format that we can use about any, I think pretty much every programming language has some sort of JSON function in it, so it can read JSON and write to JSON. We've kind of used this standardized notation as a way to interchange data. So we can take data from one program and bring it into another program, and it'll work. And we see this used a lot with APIs. So what is an API? API is an initialism for application programming interface. Essentially, it's just a software platform that allows two different applications to work with one another. And so since JSON is a file that's used to interchange data, that makes it perfect. And so we can kind of do an example here. So I'll move my comment down there. And I've got a sample JSON data file here. Let me pull it in. This is from a site called REST API example.com. It's a sample employee data file. In the module, you'll see I used a different one. I think I used maybe JSON placeholder in the example that I did in the module. But if we look at this data here, and we look inside the data, right, like we see this here, kind of an array of elements, right? We see our square bracket here. It's an array of elements that's on our data item, which that's going to become important to us later. But this is the kind of thing that you'd want to set up, I think, ideally to do your lab. Although you don't really have to do it this way. You know, setting it up as a JSON file and bringing that JSON file in is going to be a whole lot easier. I'm just going to pull this data in from this site, but I could also take this data, copy it into a .json file, put it on my own site itself, and use it just as easy. But what we have here is we basically have some kind of employee JSON file. So what I want to do is I want to go through and create a list of all of these employee names. So that's exactly what we're going to do here. And so the first thing that I'm going to do is, so I don't have to copy and paste that long variable a bunch of times, I'm going to or that long URL a bunch of times, I'm just going to put it in a variable. So I'm going to create a variable called request URL and set that equal to the link to that file. Right? So what we're going to do is we're going to request that file. We're going to get the data out of it. We're going to pull it in. And so we're actually going to do that with a predefined object inside of JavaScript, the Xmlhttprequest object. So we're going to let, or really we can do this as a var because we don't need to scope this. We can var our request as a new XML HTTP and we see we get that in our IDE right there. Parentheses at the end. So now we're creating a new XML HTTP request object, and we're going to pass that some values. We're going to say request.open. We're going to use a get to get this file. We can use get or post, or there's other methods that we can do with it. We're already not doing this in a secure manner since we're just doing it over front-end JavaScript. So we're just going to use a get request, and we're going to get that data at that URL. So request URL. So just as an aside here, this is not the way you'd want to do this if you were using like some important data that required some kind of API key to access it. Right? Since this is just like a sample file, or maybe you just want to take some data and put it in a file like this to where it's cleaner and easier to manage, but it's not sensitive. We wouldn't want to do this, right? Because remember that all this is on the front end. So if it's something that's secret or something that only you can access with an API key, you would want to use some kind of back-end language to do this. So we're going to get that file at that item. We're going to tell it that it's going to give us back JSON. So request.response type equals JSON. And then we're going to send the request. So request.send. Like that. So now we've got one more thing. We want to run a function when our request kind of loads in that will kind of take that data from the request and just put it into a variable. So when we get our request.response, or no, request.onload first. When we get our request.onload, we're going to insert a function that will give us our request response, and we'll pass that into a variable. Var employee API equals our request dot response. And so if we console logged employee API here, we would get that data that came from that request. Right? So let's do that so we can see it. Console.log employee API. And this is more of a helper function in the grand scheme of things, right? We're going to call another function here that's going to actually deal with our data, but we'll console log all of that API information, and we should see it populate our console. Well, right now we're getting a null. Which, did we do something wrong here? I don't think we did. Let me check my notes just to make sure. I think we're good. Let's try employee API.data. Cannot read properties of... I think maybe because we're in my request on load here, it won't do that. I actually need to pass it to the other function before it'll do that. So let's add a function call here for create list and pass that employee API data to it. Employee API. Right. So now we will create our function, create list, and this will be our API data that we pass into here. So now let's console.log our API data, because I believe that's what we need to do. We need to pass it to here before it'll do something. So let's try that. Yep, there's our API data. Beautiful. That's what we were looking for. So that's, let's see, where did I put that window? That is this window. But one of the great things that we can see about it here is that it's all nice and beautifully formatted. Now we see that, again, that this is in this sort of array that belongs to this data name. So if we want to get to the stuff inside of that data and get rid of all the status messages and the message here at the end and all that kind of stuff, we can just use our dot notation, dot data. So API data dot data is going to be just what's inside of this data array here. So we run that, and we see we get that back, and it's just what was inside of that array without the status messages and things like that. So if we go a step further, API data dot employee employee underscore name, which is the element that we want to get out of each of these. I think this will work. Let's find out. Undefined, yeah. So we need to loop through and get the employee names. So let's loop through here and let's get those employee names. So we're going to just write a little for loop here. So we're going to say for var employee of employee or of API data dot data. I think from here, if we wanted to, we could console.log employee dot employee underscore name. Because what this is going to do is it's going to take every object that we see in here, right? We see all these different objects. Like that's an object, it's surrounded by those curly braces. That's an object, it's surrounded by those curly braces. It's going to go through every object. It's going to find the thing with the ID property name of employee name, and it's going to return the value that goes along with that. So let's see that. Oops, what did we do wrong here? Let me go back to my notes again because it works in my notes. That should work, but it's not for some reason. Tell you what, let's do. Let's add this API.data to. Because that was just working, right? Like when we console.log that. Console.log API data.data. Oh, am I using the wrong? No. Now that was just working, was it not? Strange. For and this should be employee. Let's see if this works. Okay, now we're getting somewhere. Now it's working. So if we import employee.name, oh, it's employee underscore name. Was that the problem that we were having the whole time? Is that it's employee underscore name? And then we just get the list of names. That's exactly what we want. So now we can add them to our list. We've already put our list here, so we can just inner HTML this document dot query selector UL dot inner HTML plus equals employee name. We'll wrap that in a little list item. So we'll put a little li and concatenate that. And then we'll close our li. And so that'll put it all on our page. And it takes a second because it's a data file that it's pulling across the internet, but there is a list of names that is just using the employee names out of this JSON file that we're calling from across the internet and putting it into our site. And that's essentially how we use APIs. So that's all that I have for you for today. We'll hang out and chat for just a few minutes afterward, just in case anybody has any questions. So we'll play the music and we'll just hang out for a few minutes. If you have any questions later on, as you're watching the recording, please, contact me and let me know. But that's all that I have for you for today. Thank you for watching.